All right, so looking at questions 1 through 5 here. What angle is formed by ray xy and ray xz? Well, here's ray xy, and here is ray xz. We've got a couple different ways that we could refer to this angle here. We could call this angle 1, because right back in the corner, right here, there's that number 1. We could also give it a 3-letter name. Thank you, sir. Morning. We just started going over the review. So that is one possible name for this angle. We could also call this angle YXZ. Or we could turn that around and do ZXY. There is one other variation that we could take and turn around. On ray XY right here, there is another point. There is point V. So this angle right here we could call VXZ. The X has to be in the middle. Yes, that's a very good question. Because X is the vertex, you want the bottom paper. Because X is the vertex, it has to be in the middle. So wherever you make that turn, wherever the corner is on the angle, that point has to be the middle letter in the name for that angle. All right, name the vertex of angle 3. Let's go look at angle 3 now. All right, there's angle 3. Z is our vertex. So the vertex is just the corner where you make the turn. So here's where we turn in that angle, and the vertex is Z. So you did a good job identifying where that turning place would be when you gave the name. All right, number 3, what are all the possible names for angle number 4? Angle 4 is this angle up here. Oops. We're looking at this angle here. So there are a lot of possible names here. I'm not going to call it angle 4 again because they already called it angle 4. I need to come up with other names. Yes. 3, yes. And the middle letter has to be where you make that turn. X what? XVY, we're not making our turn at V. X, Y has to be in the middle because Y is where we're making our turn. So XYZ would work. XYZ. Yep. XYZ or ZYX. So we can take a name and turn it around. There are more names than just those 2, though. We can do WYX because W is on the same ray as point Z, so WYX would be a possible name here. If I can call it WYX, what else could I call it? XYW. ZYW? VYW, yes. V is on the same ray as point X, so VYW would work. Or we could do WYV. XY what? XYV. XYV would have us just right here. Because X is here, then back to Y, and then back to V. I'm not making that corner turn there. Yes.
VYW. Wait, no, wrong one. VYZ.
VYZ we could do. And if I can do VYZ, what else could we do? ZYV. Notice on all of these, what is in the center? Y. And when you look at our angle here, Y is where you're making that turn. So you need 1 point before the turn, you need where you're turning, and you need 1 point after the turn. So X, and then Y, and then W. V, and then Y, and then Z, or any combination of those. And we can always turn them around and go backwards as well. What is another name for angle X, Z, Y? Let me highlight this angle real quick. X, Z, Y would be this angle right here, and you're absolutely correct. Angle 2 would be another name for that. Can somebody give me another name other than angle 2? YZX. So angle 2 or angle YZX. Yes. Why is it angle 2? Do you see the 2 tucked back here in the corner by the vertex? Yep. That's why we could call it angle 2 there. You want to be looking, so I couldn't call it angle 3 because it has to be both sides are part of that angle where I made that turn. And then it's the number tucked back into that corner there. You're welcome. All right, last one here on this part. Name the sides of angle 2. So we're staying on the same angle. The sides of an angle are rays. The sides of an angle are rays. So we have to give them ray names. And I have to indicate that we don't keep going from the vertex. So my ray name has to start with the vertex. So a ray just has 2 letters like a line or like a segment. So Z, ZY could be one of them. ZY going this way. Now over the top of a ray, you have an arrow that always points to the right. The arrowhead always points to the right, no matter what the picture is doing. This first letter is your vertex. This one has no arrow. It does not keep going in this direction. The second letter, it's moving in that direction. That's telling you where to go from, and then you keep going in that direction there. So ZY would be one side. That would be this side right here. ZX would be the other one, with the arrowhead over the top. Vertex has to go first because that is not a point that we go through. It is a stopping point. It is an end point. You had your hand up, sir. Did you have a question about this?
No, I was going to ask, why are we having an arrow on the Y and X if there's no arrow going there? But then you already explained it.
Yeah, it's because so this angle, let me see if I can get this. This angle continues on past that endpoint, even though in my picture it stops there. The vertex we don't keep going through because that's where we would make a turn. It's kind of like if you're giving somebody directions. They're coming from their house, but you don't know exactly where they live. So you're like, you know where the McDonald's is? And they're like, yeah, I know where McDonald's is. You're like, okay, I want you to go past McDonald's, and when you get to the next light, you're going to turn left. That would be your vertex where you make that turn. And then you're going to keep going down that road until the road doesn't stop when you get to your destination. The road keeps going. So you like that road continues on. That's why we have that arrow there. But where we make that turn, that's like this fixed point. I don't want you to keep going straight. I want you to make a corner there. Does that help a little bit?
Yes.
Okay,
Thank you.
you're welcome. What else would you guys like to see from the review? Yes. Numbers 6 and 8? Yes. So number 6 first. It says in the figure, ray TP, this is ray TP, and ray TS, this is ray TS, are opposite rays. That means they form a line. So what they're telling me there is that this is a straight line here across the top. And then it says that TQ, here's TQ, bisects angle RTP. Now here's R to T, and then we make a turn at T, and then we go out towards P. So this is the angle that is being bisected. What does bisect mean? To cut it in half. So what's true about these two angles now? They're the same size. So this angle is the same size as this angle.
Set them equal to each other.
Can. All right, so let's read through this. The measure of angle PTQ, PTQ. So this angle right here is 12x plus 4. And then angle RTQ, RTQ, so this angle right here is 15x minus 5. And you're absolutely correct. Those two angles are congruent, so we are going to set those measurements equal to each other. So angle PTQ is congruent to angle RTQ. That means the measurement of angle PTQ is equal to the measurement of angle RTQ. Angle PTQ is 12x plus 4. So we're taking that and setting it equal to RTQ, 15x minus 5. And now we're going to solve this for x. First thing I need to do is get my x's on the same side. So I'm going to minus 12x from both sides. That leaves me with a 4 on the left-hand side. And 3x minus 5 on the right-hand side. Absolutely correct. Add 5 to both sides. 4 plus 5 is what? 9. So I have 9 equals 3x. Ran out of room. Let's bring that around here. Then we divide both sides by 3. So x is equal to 3. Do I stop there? No, why not? Yeah, it says find RTP. RTP.
Yeah.
That's this big purple angle, right? So I've got a choice here. There's 3 different ways I could do this to get this answer. Do you know one way?
You find out one equation, then you multiply by 2.
Yeah, I could plug in here into just one of them and times it by 2 because these are the same size. Or I could plug in here and times it by 2 because it's going to be the same thing as up here. What's the third way I could do this?
You could add them to both equations and then add them.
Yes, I could plug into both of these equations. I'm going to get the same number, and then I can plus them together. So I could do it either of those ways, or any of those 3 ways.
Which is kind of time consuming.
Yep, the easy way,
I have a question.
yes.
The RTP,
Mm-hmm.
why is it not equal to 90 degrees?
Because there was no right angle mark here. Remember, that's not something we're allowed to assume from a picture. If it looks like a right angle, that does not matter, because some people are better artists than others. So what looks like a right angle on my page might not be. And what doesn't look like a right angle on my page might actually be a right angle. So we can't just go based on the appearance of it. Okay, so the measure of angle RTP is equal to 2 times the measure of angle PTQ. So the measure of angle RTP is equal to 2 times 12x plus 4. Measure of angle RTP is equal to 2 times 12 times 3 plus 4. So the measure of angle RTP is 2 times 40, which makes it 80. It is 80 degrees. 2 times 3 is 36, plus 4 more gives me 40. So this angle up here is 40 degrees. And the bottom angle would also be 40 degrees because it is congruent. And when I put the 40 and 40 together, I get 80 degrees. Before I go on and do number 8, I want to talk about number 7 for a minute, just because we had a skills check problem like this one on the first skills check. And overall as a group, between all 4 of my geometry classes, we struggled with this one. So I'd like to take the opportunity to talk about this one for a moment. Because if it's shown up on the skills check and it's shown up on the test review and we practiced it during class and it was on the homework, where do you think you're going to see this? It's probably going to be on the test. Okay, so I'm going to redraw the picture down here just so I don't mark up the other one since I've already got it all marked up. All right, we have point S here, point T here, point P, Q, and R. All right, it says the angle STR is 102 degrees. So this angle right here is 102 degrees. And what do we know about these 2 angles right here? They're congruent because they told me back here that TQ bisects RTP. So these 2 angles are the same size. And we have to somehow figure out how big PTR is and then how big QTR is. Let's find PTR first. I'm going to highlight over what it is that we're finding. P, back to T, and down to R. Ignore the fact that this angle is being cut in half right now. Yes?
Are we going to set it to 180?
Mm-hmm.
And we're going to divide the answer by 2.
Yes. That's exactly what we're going to do. So for right now, I'm ignoring that this line is in the middle. These 2 angles, the orange one and the green one, add to 180. So 102 degrees plus the measure of angle PTR equals 180. I know that these 2 together equal 180 because they're a linear pair. I know that this is a straight line across the top because it told me that those were opposite rays. They form a straight line. So then I'm going to minus 102 from both sides. What is 180 minus 102? 78. So the measure of angle PTR is 78 degrees. So from here all the way around to here is 78. We're going to divide it by 2 to find out how big those 2 little pieces are in the middle. So the measure of angle QTR is equal to 78 divided by 2, which is 39 degrees. So this little angle over here is 39 degrees. This little angle over here is 39 degrees. All right. Sorry, I know that wasn't an asked for one, but I know we had a lot of problems with that one. And all things considered, It shouldn't be a horribly difficult problem. You minus from 180, that's one of your answers, and then you cut it in half. That's the other answer. Yes, Darcy?
So QTR is 39 degrees.
What'd you say?
QTR is 39
QTR is 39
degrees.
degrees, yes. Yep, 39 degrees. All right, number 8. Number 8. This is like one that we had on the skills check yesterday. Here's this vocabulary word. When we get to the test tomorrow, I can't tell you what the vocabulary that we've studied in this module means. You have to know what complementary means. You have to know what supplementary means. You have to know what perpendicular means. You have to know linear pair, vertical angles, and adjacent angles. So there's like 6 big vocabulary terms that we've studied. Complementary means what? Means they add to 90 degrees. There were a lot of the skills checks that I graded yesterday where we had the right idea. It was 2 things that add together, but we got complementary and supplementary mixed up. And so we ended up missing the problem because of that confusion there. Here's the way I keep this one straight, because the words are very similar, right? Which number's smaller, 90 or 180? 90. Which letter, if I were to put complementary and supplementary in alphabetical order, which word would come first? Complementary, because C comes in the alphabet before S, right? So 90 comes first on the number line, C comes first in the alphabet. 90 and the complementary go together. Supplementary comes later on in the alphabet, 180 comes further down the number line, supplementary and 180 go together. All right, so complementary, 2 things add together to be 90 degrees. So I know I have to have these 2 pieces. So I'm just going to kind of start setting up my problem like this. It says angle M is 38 less. Yes, so 38 less means I'm going to minus 38. It's not 38 minus. That makes a big difference. Here's the way I think of this one. I think about it with money, because I'm much better with money on some of this stuff. If you've got $40 and I have 38 less than you, do you do 38 minus 40 or 40 minus 38? 40 minus 38. So if it says less than, it's going to be minus and then whatever number they told you. Not M minus 38, it says M is equal to 38 less than angle N. I don't know how big angle N is. They're giving me this relationship for the measurement of angle M. So X minus 38. And the measure of angle N is just X. So these are the 2 things we're going to add together, X and X minus 38. I know that means I have 2 X's there. One of the things that I saw a lot of was this. And if you do that, you're telling me that that angle is a right angle, which means it can't be complementary to anything because it's 90 all by itself. You have to add a whole nother angle to it. So now I combine my like terms. I get 2x minus 38 equals 90. Add 38 to both sides. 128, so 2x equals 128. X equals 64. You guys are talking faster than I can write, but I love it. 64. Okay, so what does that tell me then?
That angle N is 64.
Yep, measure of angle N is 64 degrees. How do I find angle M?
64 minus 38.
Yes, measure of angle M.
Is 26.
64 minus 38. You said that's 26?
Yes.
What did it say at the beginning about these 2 angles? They're complementary, so how can I check this now? Add them. 64. If they equal 90, then we did it right. 6 plus 4 gives me 10. So carry the 1, bring down the 0. 6, 7, 8, 9. 90 degrees. We are good. All right. What else would you guys like to see? We've got about 13 more minutes. That is like 2 long problems or 3 short ones. Number 11, absolutely. 26 after that, so let's do 11 and then 26. I love it. Name 2 adjacent angles. In order to be adjacent, they have to share a side. So there's tons of right answers on here. I'm going to start by picking any angle I want to. Let's pick this one. You guys okay if we choose that one? All right, so what would a name for that angle be? GBC. Don't forget to put the angle marking at the beginning. Angle GBC. Remember, we also name planes with 3 letters, so you got to put that angle marking in there so that I know you're talking about the angle. Angle GBC, and now I need something that is side by side. So it either has to share this side or it has to share this side. So I could do this angle up here, DBC, or EBC, or you could call this one up on top ABC. You could call the one down on the bottom, you could call CBF. Any of those would be correct. And I didn't have to start with the blue angle that I started with. I just picked any angle I wanted to in the picture. And then I found another angle that shared a side with that. All right, and then you said 26? 26 was the other one? Awesome. Let's go check out 26 then. Too far. Number 14? Yep, let's do 26 and then 14. Angles R and T are complementary angles. What does complementary mean again? Adds to 90 degrees. Not each one is equal to 90. Together, they make 90. So when I see complementary or supplementary, I've got these 2 blank lines and then equal to. If it's complementary, it's equal to 90. If it's supplementary, it's equal to 180. Measure of angle R is 3x plus 12, so that goes in one of my spots. Measure of angle T is 2x minus 7, so that goes in the other spot. And now we're going to solve this. So I'm going to draw a fence because I'm combining things on the same side. When I put the 3x that's over here together with the 2x that's here, I don't minus anything. They are on the same side. That's like having things in both of your pockets. If I've got $3 in one pocket and $2 in the other pocket, how much do I have? $5. So this is 5x. And then we do the same kind of thing with our constants, with the things that don't have variables. I've got a positive 12, and then I'm going to take away 7 from that. 5. And it's a positive 5 that I have left over because 12 was bigger than 7. Equals 90. Then I'll minus 5 from both sides. We get 85. 5x equals 85. And then we divide and we get 17. You're absolutely right. So x is 17. We need to find the measurements for angle R and angle T. So now I need to take this and sub it back in. So in 3x plus 12, we're going to put 17 in the place of x. So 3 times 17 plus 12, 63. So the measure of angle R is 63 degrees. Notice I put degrees on this, but I didn't put degrees on the x. X wasn't an angle. I had to plug x into something to get the angle. Measure of angle T is 2x minus 7. So 2 times 17 minus 7. What is 2 times 17? 34 minus 7? 27. So angle T is 27 degrees. Should check that it adds to 90. 63 degrees plus 27 degrees. 3 and 7 makes 10. Carry the 1, bring down the 0. That is 90, so we're good.
I have to ask a question. Like, if you ask and like you fall like when you're looking for a measurement of angle R, if you're looking for T, can you just like subtract like 63 from 90 to get T?
So the only issue with doing that is that then I can't check to make sure my two answers add to 90. Could you do 90 minus 63 to find angle T? Yes, but then to check, you would need to plug in here to make sure that you got the same answer. So the problem is, if you did it wrong back here, and so when you plugged in here, you got something that wasn't right, you're going to get a wrong answer for this one. So just be careful with doing that. But is it mathematically accurate? Yes. If you do it on the test, will I give you full points? Yes. Yes. What is the symbol on? You said number 18? Let's go look at number 18. Ah, this symbol right here. That's perpendicular. Perpendicular. So makes right angles. Means it makes right angles. So PQ, let's go look at PQ. I know I need to go do number 14. Here's line PQ. Do you see a right angle mark there anywhere?
Yes.
Yes, right here we have a right angle mark. PQ is making a right angle mark with what other line? Is it making a right angle with this? CO, or we could call it CD, or we could call it OD. We're not naming the angle, we're naming the line that it makes a right angle with. So CD. Or you could call it CO or DO. Or you can switch any of those letters around backwards. DC, OC, OD.
When is this?
Test is tomorrow.
Tomorrow?
Yep. All right, 14. 14. If the measure of angle DBE, this angle right here, is 67 degrees, then GBC, which is what I have marked here in dark blue, will also be 67 degrees. Why? Yes, these two angles are vertical angles, and vertical angles are always the same size. Always. Yes. They are not adjacent because they don't share a side. They only share a vertex. To be adjacent, they have to share a whole side. So a line segment has to be shared. Vertical angles are when you have an X, like this. They are the opposite angles. So like these two, or these two. So vertical angles are opposite angles. You said number 16? Yes. And then that'll be the last one that we have time for today. Sorry, you said 16? Okay, sorry, I just wanted to make sure. I only have time for one, sweetie. All right, I've got X's and Y's that I need to solve for here.
16.
Which one should we find next? Or sorry, which one should we find first on number 16? The X. I have two X's here. And what's true about this angle and this angle? They're equal to each other because they are vertical angles. So they are congruent, which means we're going to take their measurements and set them equal. So 3x minus 16 equals 5x minus 110. Get the x's to the same side, so minus 3x from both sides. Negative 16 equals 2x minus 110. Nope, add 110. If I add 16, it's going to give me a 0 on the other side and too much stuff around x. Remember, I want x alone, so I got to get rid of the things that are over on the same side as x.
I said 110.
You said 16.
So my mom's good.
What is negative 16 plus 110?
Negative 4.
It is 94. It's a positive because the 110 is bigger than the 16. Then we divide both sides by 2. Should get 47. All right, so that found us x. Now we still need to find y.
Y plus 3 times 47 minus 16 equals 180.
Yes. This angle and this angle. Do you see how they share this side right in between them? That means they're adjacent angles. Specifically, these adjacent angles are what special kind? Linear pair. They are adjacent angles, and their non-touching sides make a straight line. So whenever I have an x, the adjacent angles will be a linear pair. And linear pair angles add to 180 degrees. They are supplementary. So two things that add to 180. One of those is y. The other one is 3x minus 16. And we just found out that x is 47. So I have y plus 3 times 47 minus 16 equals 180. We're going to do all of this in the calculator next. 3 times 47 minus 16. 125. And then I subtract 125 from both sides. We get 55. Beautiful. All right. There's our timer. I did record all of this session. Nobody's faces, it's voices only, but you can see the screen in the video. I will be posting this video along with my other 3 geometry classes. I'll be recording all of their review sessions as well.
Lying my voice.
Yeah, you'll be able to hear your voice, probably faintly. Probably faintly. It would be a good idea, if you have questions about some of the ones that I did not go over in the review, to check out the videos from the other classes. Also, I have posted the answer key. If you go to our class Canvas page for today, so you go to modules and you find today's date, the 28th, it says review for module 2 test day 2. If you scroll all the way to the bottom, the module 2 review key is posted down here, so you can find all of my answers. The videos aren't posted yet because I haven't made them yet, but they will be here. The videos will be located right above the notes. There will be 4 videos in this section here with the notes at the very bottom. You will be turning in your reviews tomorrow, so please make sure that you have completed those.